Welcome to AP Calculus AB.
Hi, Fagan.
He's right there.
All right. So,
Last time I was
check his ID. Sorry, Ari.
No, that's great.
Oh, okay. You just showed it to me. Okay, guys. So rates of change and tangent lines. This is an important section. Probably, yeah, the most important. What?
I don't have it.
Oh,
Oh, don't worry. This is only the.
that's ill timing.
Wait.
I have a piece of paper you can use.
You can use mine.
Oh my god,
Today?
you missed it.
Samuel told us that we were going to do a lab where we fire like a ball from
A
the
ball from
And
the
Steven asked,
a
are
lighter
we really
cannon,
using
like-
real fire for this?
No, like a light of fuse, and then the ball would shoot
It was
out.
so
That's
funny.
stupid.
He thinks we're shooting a cannon.
Yeah,
No,
we're
like
like,
a fuse,
Steven.
and then the ball would shoot.
We're like,
Oh,
no.
Yeah, a fuse. That only works
Okay.
if there's gunpowder.
All right. Great story. Great story. Okay.
I'll use paper then.
All right. Average rate of change. So,
Wait, didn't
we
you
talked
learn this
about.
at the beginning?
Yes, we did. We're taking this average rate of change, which we talked about previously. Average speed. Okay, rate of speed is a rate of change. Speed is not the only type of rate of change, so now we just kind of generalize it. So basically you need to have a time interval. So you have to have a start time and an end time, and you have to have a function. Okay, or at least values to work with. And this is the same equation that we worked with before. Okay? So average rate of change can be applied, like I said, it can be applied to various things. It doesn't have to be speed. We can look at the average rate of change of this function. So here we have square root of 2x plus 1, and we want to find the average rate of change from 0 to 4. So we want f of 4 minus f of 0 over 4 minus 0. Right, so basically what I'm saying is from this point to this point, what's the slope of the line? Now if I have the graph, this is really easy to see, but let's do it by, since we have the function, and then we can confirm that. So we have square root of, so 2 times 4 plus 1, and then minus 2 times 0 plus 1 in the square root. So we have square root of 9, 3 minus 1, so we get 1/2. So is that the same slope that if we compare those 2 points? Yeah. If we go up 2 and to the right 4, that does confirm that that's the average rate of change. Okay. All right. Yes, sir.
I hate to be a broken record, but if we have the graph, can't we just count?
Yes. You won't always, in fact, I never give you the graph.
Okay.
So if you,
It's really not that hard to do this.
right, so I'm not going to give you, I'm doing that for you guys right now so you can make the, I'm a visual learner, so like if I do an equation, I want to know what that means graphically. So I like to see the picture when I first learn about something. I know a lot of you are the same. So that's one of the reasons that I throw the graph in there. Some of these will be really obvious. Yes. But on the quiz or test, I'm not going to give you a graph. Yeah. So let's take a look. F of pi minus f of 0 over pi minus 0. Now again, what does this mean? Well, here's f of 0. Here's f of pi. What's the slope of that line? So I should get 0. So yeah, obviously looking at the graph makes sense. So let's just confirm that algebraically. So I'm going to plug in pi. So we have 2 plus sine of pi minus, and then 2 plus sine of 0. But what's sine of pi and sine of 0? 0. So I basically have 2 minus 2 in the top, So I get 0 over pi, which is 0. So yes, that confirms what I could see graphically, that it does have to be the same. Okay, so now we have a figure. And this graph is showing the growth of a fruit fly population in a controlled experiment.
Where are those damsel flies?
No damselflies, just the fruit fly. So we're going to compute the average rate of change and the slope of the secant line. So secant line has to go through 2 points. So if you remember back to geometry, I know, geometry. I don't have a... So, oh, don't. I better not hear that from anyone else.
Yeah, I did. I had
You know my feelings.
I had a horrible geometry teacher.
Okay.
Way worse than this case.
Okay, so here we have a circle and a secant has to go through 2 points versus a tangent. Oops, that's supposed to just. And a tangent line just touches the circle at 1 point or intersects at 1 point. So we can have any kind of curve and also compare the secant line and the tangent line, which is something we do often in this class. But we're going to start out with this secant. So here we have our 2 points. So what does this represent? So these are the time in days, and this is the population. So we're going to look at 23 days. There's 150 fruit flies, and then we want to compare that to Q. So after 45 days, there's 340. Got it? Okay, so we want to compute delta P over delta T, so the change in population over the change in time. And I know, just kind of ignore that it says it here. Let's just write it out. What's that look like? It's 340 minus 150 over 45 minus 23. Plus, I don't like that they rounded to 9. Let's go to maybe a little bit more decimal places to begin with. So if you have your calculator, what does that come out to? 8.636. And they rounded it to 9 flies per day. Okay. Good? Okay. So
We could have 8.6 flies.
no, I know. So they're gonna say, whoops.
What if we have 8 flies with some wiggle ones?
So they're gonna say,
Dead fly.
so they're gonna say about 9 flies per day. Now, explain to me what does that mean? So it's not exactly 9 flies, but again, this is something that we need to be able to answer, like when we get to free response questions. This is very specific. This is only between days 23 and 45. Does it grow at a rate of 9 flies per day? What if I chose 2 different days? What if I said from day 10 to day 23? That's going to be different. Now, what would be the scenario where it would stay 9 flies per day the whole time? So, but what would have to be true about the graph if the average rate of change stayed the same? It would just be a line, right? And the slope would not be changing. But we know with population and most real world scenarios that things do not stay constant, right? I mean, not they usually don't, right? Right. So that's why that's where we have the importance of finding the average rate of change on a specific interval. And now, and just relate that, it says secant slope, that is the secant slope. So I just wanted you to make the connection that the average rate of change is the same thing. They're one and the same. So if I ever ask you for the average rate of change, you know that's the secant slope. If I ever ask for the secant slope, that's the average rate of change. Okay. Now, let's say we want to figure out exactly the rate of change at 23 days or at 30 days. So now we're thinking of not the secant line, but a tangent line. Well, how do you find the slope of a line at just 1 point? Magic. This is where it all happens. So here's, this is a lot of words. So basically, here, Fermat came up with this solution back in 1629, in case you're wondering. We could put that on the timeline. It's still there, I know.
We should actually.
We should.
Well,
actually-
Pierre
Please just
Fermat.
mess with the
There's
system.
Came up with-
starts at 17.
I know, we need to extend it a little. So he came up with this solution of taking a secant line, all right? So say we start with a secant from P to Q. And what if we move that point Q closer and closer to point P? So that P and Q are so close together. So in other words, the distance between them has a limit that goes to 0. Then we can still find that slope. So that's essentially what we're doing here. Okay, we're taking this point, we're moving it closer and closer, and so we're taking 2 points where their distance between them is going to 0. So here, what's that? Okay, well, I plan to. That's, I mean, but usually it's hard to read a math book and,
That's why you get paid the big.
oh, yes, you got that.
That's why she's a teacher. For the big bucks.
Let's look at the slope. Okay, take this point here and this point here. Let's just find the slope of that, okay? Y2 minus Y1. So we have f of a plus h minus f of a over a plus h minus a. So I get f of a plus h minus f of a all over h. He said, isn't this the same thing as the instantaneous rate of change? And yes, it is. It's no accident. What do we throw in there for instantaneous rate of change, which is on the next page? What do we want h? So h is that distance between the 2 points, right? This is a, this is a plus h. What do we want to make h? We want to make that a limit as h goes to 0.
Oh, so it's like exactly like.
Yep.
Yes,
Yeah.
see? It's all related. It's not an accident. Okay? Again.
You should just shuffle the lessons, like take all the lessons and then just switch the numbers randomly.
Please don't do
That
that.
wouldn't,
So
that'll
that
never
like
work.
chapter 2 we just go from that like thing we can't do yet, like just random.
It'd be
Or we
so
could learn how to
dumb.
do it step by step.
We could learn how to do it step by step.
That would be dumb.
Just
Okay.
mix all the lessons up
So,
and do it from the whole-
Slope of the curve. So this is big. This is really huge. So far, your entire life, if you've had to find the slope of a line, you needed 2 points. Now, just one. You just need one.
Yes.
Oh, yeah.
A point. Isn't that exciting? Okay.
Except it's way harder.
Nah, we could do this. We got this. Now, why is this useful? Well, it's very useful when you don't have straight lines. If you have a straight line, you can just see the slope, right? But when you have a curve, the slope is changing, right? The slope over here is different than it is here, which is different than it is here. So it's changing according to the location of the point. Good? Okay, so we want to find the slope of the parabola, y equals x squared, at the point 2, 4, right here. So I'm looking for, kind of visualize a, oh, that's not a very good tangent line, but picture you have a tangent line here, and I want to come up with a slope. Could you maybe approximate it? What do you think it might be? Slope.
3.
Rise over run. You think about 3? 2? Okay, let's check. Let's check. So here's the thing. This is an important formula, so I'm just going to write it out. You don't have to write it out again, but it's a plus h minus f of a all over h. Now, what is my a and what's the h? The h I'm going to leave in there, okay? H is what I want to take the limit as h goes to 0, so I'm going to do some algebra and manipulate that expression to try to get that h out of the denominator. What's a? What do you think A is? It's 2. It's the x value. So sometimes we'll see the formula as f of x plus h minus f of x, right? That's how we had it before. Sometimes we'll see it with the letter A. It's the same formula, okay? So let's do that. Alrighty. My goodness. Okay. I know. I'm taking it step by step. I'm going to start skipping some steps. I'm going to do future examples, but just so you can see each step in the process.
Oh man.
I know. I keep writing this limit. You can't drop the limit until you actually plug it in. So f of 2 plus h. Well, I should, but I don't.
Wait, when you plug it in, didn't you already? Oh, okay. I get it.
Yeah.
Wait, but then
But,
the next.
yeah. Okay. So what's f? Well, all right. I have y equals x squared. F of x is the same thing. Okay.
Wait, how can we take out the age? Wait. Because
What?
We're about to find out.
Wait, what did I do? I took out an age?
Nothing yet. That's the problem.
I know. I'm like, maybe I'm taking like 2 baby steps. Like I like to write it all out in the beginning so
Just
you
write
can see.
each number and explain to Steve why.
What is f? Well, I didn't have it defined as f. I had it y equals x squared. So composition of functions mean whatever I have inside the parentheses, that's what I replace for x.
Yeah.
So 2 plus h gets squared.
I know that.
And then minus 2 squared. Now, of course, we already have the y coordinate is 4. I'm just showing you that when we plug that in, that's how we get that. So now, are we still confused on that last step,
I
or?
wasn't confused. I was saying that she doesn't have an age with it, so we're gonna end up with 2 divided by 8. But this is h to 0, so we can just wait.
Let's just wait for it. Wait for it. Okay.
For 1 second.
Okay. I'm multiplying everything out, right? Our goal is to get rid of the h in the denominator. I said that at the very beginning because we can't plug in h equals 0. We can't use that limit. We can't apply it until we.
Okay.
Okay, so you could, on a calculator, you confirm this by plugging in really small values, but I need you to be able to do this algebraically. Because again, what's the whole point to this? We're finding the slope of a curve at a particular point with just that point. In other words, we don't need 2 points to find the slope anymore. So that's the significance of this formula. Now, I am almost ready to, I'm going to factor out an h on the top. And if I could factor correctly, that would help. Oh, it happens. Do you have to
We have
factor?
to show this step.
Listen, I'm showing every little step right now, guys, okay? This is AP. I'm just showing you in the beginning.
Sorry.
I know. To do stupid.
Okay, now I can... No, seriously. It's like... It's water. How... I had to use that on my son this morning. Spraying him awake. I wasn't waking up. I was like, wake up. I'm like, do you want me to spray it with water? He's like, no. I'm like, watch me.
And play really loud music. I swear to God.
I'm so mean.
But then you like.
Or just play country music. Then you'll
It's
get
not
no way
about
down.
drugs by the time
Yeah,
you
if you put country music on like 10
No,
feet
I
from
woke
him,
up to
he'll
a
have to get
fantastic
out of
song
the
this
bed and
morning.
turn
I
around.
was so happy.
Okay, guys, you missed it. You missed it.
It's 4 plus 8.
What's the slope?
4.
4.
Whoa.
What about the plus 8?
I thought we could.
Okay,
We
hold
can't
on.
because it's not on the denominator.
You can't plug in 0.
Oh, and it's the
Yes. Okay, so our goal here, and our goal every time we use this formula, it's always going to be over h. So our goal always when we're using this instantaneous rate of change formula is to get rid of the h on the bottom because we can't plug in with an h on the bottom. And if you get to a point, algebraically, where you can't cancel the h on the bottom, then either you haven't done enough or you've made a mistake somewhere along the way, okay? Once you're able to cancel, then you can plug in h equals 0.
Is it always going to equal the antibody?
That's just a coincidence. Because let me tell you, like at a different point, it's not necessarily going to be the same. I mean, and especially like a different curve. It just so happens that that worked out in this one. Okay, good. Are there any other questions on this? Because you really got to make sure you know, understand it.
It says right in the equation.
What? Oh, did I miss the equation part? Oh, thank you. Write an equation for, oh, that's easy. That's easy. So, the equation of the tangent line.
Y equals 4x plus 1.
Okay, so what do we need to write the equation of the tangent line? We need a slope, and we need a point. Now, remember, this was our slope, and we were given the point as 2, 4. So it's y minus 4 equals 4 times x minus 2. So, sorry, missed that last step. So that's the actual equation of the tangent line. Okay. So again, you have a point, you have a slope, you guys can write the equation. All right, next page. So now let's say we have a graph 1 over x. Recall what 1 over x looks like. It's like that. Okay. Again, it's a curve, so the slope is constantly changing. It's going to be different slopes at different points. So for part A, we want to find the slope of the curve at any point x equals a. In other words, we want to find a formula. And then we want to find out where does the slope equal -1/4. So I'm not giving a particular point this time. We're going to find the point where it has a slope of -1/4. What does this slope of -1/4 look like? Maybe.
Like this one?
So maybe like here. Like over here maybe somewhere. Maybe. Do these also have negative slopes?
Yeah.
Yeah. So there might be more than one place.
Do we have to solve the problem?
Yes. If it says where and there's 2 places, we got to write both. Okay, so now we want to write out it's f of a plus h. So what is f of x? It's 1 over x. So do I need to, you want me to write out the formula? Or are you okay? So if I go right to this, oh goodness, we're like,
We're so straightforward.
gotta like play referee in this class or something. Oh, goodness.
You're already wearing the
All right,
last.
so tell me.
I also like how you're repping class of 2018. Black and white.
Oh, wow. Original happy
No,
colors.
you're
Oh, my clothes. I was like, okay. All right, we're just gonna continue. So, are we okay with that? Good. Okay, great. Now, we got to do some algebra to try to get rid of that h on the bottom. So, right now, what we have to work with is it's a complex fraction, meaning you have fraction within a bigger fraction. So you want to think about what can I do to try to simplify that.
Simplify the top.
Okay, let's do that. Let's simplify the top. So maybe I want to multiply the top. Let's find a common denominator in the top. So I'm going to multiply by a over a here, and I'll multiply this one by a plus h over a plus h. I'm not going to do anything with the h on the bottom. The h on the bottom is something we'll deal with later.
Oh,
Okay. All right.
leader of our school.
Okay.
Knocking over.
So I have a over a times a plus h minus, and then I have a plus h in the other fraction. Again, I'm writing out quite a few steps here just so you can see the process. If you wanted to combine everything all at once, I'm fine with that. So don't forget, with that second fraction, that you have to distribute that minus sign. Thank you. So I have basically a minus h over a times a plus h. Don't distribute, okay? It's just easier if you don't. And it's all over h. We're getting somewhere. We're almost able to cancel out that h. So a minus a, we get to cancel. I have a negative h. And if you remember what we did some of this before. Now I'm going to rewrite this as negative h over a times a plus h. And instead of dividing by h, I'm going to multiply by 1 over h.
Exactly. See what happens when you wait?
See? You got, that's true. You got it.
It's working.
I know. I've taught this class enough times that
She knows
it's like I
every
know
question you
what
ask.
questions usually are, and I'm not saying always, because there's always some surprises, but.
Steven is gonna surprise you.
Okay.
Yeah, we can guarantee you that one.
Okay, so I'm going to cancel this out. Don't forget there's still that negative 1 here. Now, I've done it, right? We've actually canceled the h on the bottom, which means I can now try to plug in 0. And can I? Yes. I get negative 1 over a squared. That's part A, right? Because this is 0, so hence a on the bottom. Now we get to look at part B.
Wait.
Oh. Yes.
I thought you can't multiply the denominator.
But it's a plus 0, so it's
Oh, so it doesn't make it. Okay, yeah.
we're good. So now part B, where does the slope equal negative 1/4? So, yeah, what do we want to? So
You just put 2 into a, and negative 1 over 2 squared is going to be 4.
wait, say that.
Well,
So we
it's
get
also- it's
where
plus
we
or
want to set that
minus.
equal to the equate, right?
Right, you set that equal to 1, negative 1 over 4, so it's plus or minus 2.
So we want it equal to negative 1/4. So negative 1 over a squared is the same as negative 1/4. Now, we have a rule, I call it, it's just reciprocal rule. You can cross multiply if you want, but you can just make this a squared is equal to 4. You take the reciprocal of both sides. Also, the negatives just cancel. So we get a is equal to plus or minus 2. Now, where does the slope? So, could we find at the points? So you could say, so negative 2, comma, what would be the y coordinate?
Or
Negative 1/2. And at 2, 1/2. Where am I getting the y coordinates? I'm just getting them from the original function. So I have. Now usually, if I ask you where, I'm usually just asking for x value, but it's good practice to also find the y coordinate. Good? Okay. Next one. At what point is the tangent to f of x equals 3 minus 4x minus x squared horizontal? Well, you can actually do this without any calculus, because what kind of graph is this? It's a parabola, and right, and it's upside down. So picture, where would you have horizontal tangent? At the peak, the vertex. And so could we find the vertex of this? Yes, but we don't want to because we want to practice our lovely formula. So when it says horizontal, we want m to be 0, right? So let's go through and find, just because we do need to practice the formula. So we want what? This is the same thing. So basically we're going to leave a plus h. So we want to do the f of a plus h minus the f of a all over h again. But instead, remember the last one, we set it equal to negative 1/4. This time we want to set the slope equal to 0. So I have 3 minus 4 times a plus h minus a plus h squared, right? Minus, and then I have 3 minus 4a minus a squared. Just remember you have to distribute that all, and it's all over h. Now, it looks really messy, But this, you'll see, if as long as you plugged everything in correctly, you're going to get stuff to cancel after multiplying it out. So what do we have? We have 3 minus 4a minus 4h minus a squared minus 2ah minus h squared minus 3 plus 4a plus a squared. All that over h. And now the canceling begins. Oh, there's an A. I think I said it and I just didn't get in there. Okay. Yes, because that would be an error. That would be where I would get to the end and I wouldn't be able to cancel that H because I'd have an extra term. So that's the nice thing about these problems, because you have a way to kind of check. You know that if you can't cancel the H, that you made some kind of algebraic mistake. Okay, so now what can we cancel? We can cancel the 3's, the 4a's, and the a squareds. And we should be left with only terms that have h in it in the numerator, right? We're good. So what do we, so I like to factor. If you can cancel it without factoring, it's okay. I think it's a good habit to get into factoring. You could. Right, and then we can cancel. And now we can substitute in. Okay, so what do we get?
4 minus 2.
Now remember, this is all equal to our slope, which is m. So that means that parabola, I can find the slope at any value, right? So if I said, oh, what's the slope at when x equals 1? It's -6. Right? But we're not doing that in this case. We're looking for where is it horizontal. So we want to make 0 equal to that. And what do we get? -2? What's that? And then what's the point? So f of x has a horizontal tangent at -2. Yes? -9. Okay. Excellent. Any questions? Okay. All right. So we have till 10.
That -2 where?
Where did I put a
Where'd you get the -9?
Oh, plug it into the original. All right. So we have 20. Okay. This is just a continuation.
You have to know what you're doing in this.
It's
Tough field.
oh, we messed up on our mental math. See, I didn't check it. Okay, let's see. Oh no. Let's see.
It's 7. Yeah, my bad.
Positive or -7?
Negative signs are hard.
Wait, 3 plus 8?
Yeah, sorry, Ronan.
You said -7.
Wait, so where did -2?
See, you always check. See, usually I have my solutions in front of me, and I don't today. I mean, I have them right here. I just trust you guys sometimes, and then see what happens. Okay. Okay. Yep, see, right there, -7. Should have looked. Okay. All right, normal to the curve. This is quick, easy. Normal is just a line that is perpendicular to the tangent. Okay. We don't call it perpendicular because perpendicular is usually something you reserve for straight lines. But now we're taking a curve and we're saying, okay, here's a tangent. The line perpendicular to that is the normal line. Okay, so let's write an equation for the normal
Why are we setting societal standards?
to the curve here at x equals 1. Okay. So first we have to find the tangent.
Perpendicular K.
Okay, so find
This is an inside joke.
the tangent slope first. So 4 minus, and this time we do have the value of x. Remember, x is the same thing as a. So it's f of 1 plus h, so it's going to be 4 minus 1 plus h squared minus, so f of 1, so 4 minus 1 squared, which is, you can write 3, but just showing, and that's over h. So I have what? 4 minus 1 minus 2h minus h squared minus 3 all over h. The 4 minus 1 will cancel the 3 at the end. So if I take out an h, I'm left with a negative 2 minus h on the top. So what do we get for the slope? Just negative 2. Now that's the tangent, so that means the normal slope is equal to positive 1/2 because we want the opposite reciprocal. And now the normal line y minus y1. Okay, we have the x value is 1. What's the y value? So it's y minus 3 equals negative, or sorry, 1/2, and then x minus 1. Good there? Oh, so so our point, f of 1 would be 4 minus 1 squared, which is 3. So our point is 1, 3. Okay. You know what, it's up to you if you want to do this one again. We've actually done this. It's just revisiting it. It's y equals 16t squared, the speed of the falling rock at 1 second. Do you want me to go through it? Okay.
For review.